Hello, everybody. Thanks for joining. And I have the pleasure today to talk about a very interesting topic. We call it model level merge, why SysML v2 needs LemonTree. So I would like to explain what we contribute to the new standard SysML v2 with our established tool LemonTree, which is a different merge tool for models. And I would like to explain to you why it's necessary to have a model merge rather than just a textual merge, what LemonTree can do to support that, and what our vision is to contribute to the community and to the market, how we can support this new standard that is now enrolling to the systems engineering community. So my name is Philip Kalender. I studied software engineering and IT consultancy. I work in the context of MBSE for more than 10 years now. I'm an OMG SMC member as well as INCOSE member. So I'm contributing to the standard as well, together with colleagues of Liebe for developing and maintaining new ideas in SysML v2 especially, and in the INCOSE working groups as well. And at Liebe, I'm responsible for consulting and training. And basically, you can ask me anything about modeling, Enterprise Architect, or other modeling tools, and I try to help you out. And I'm also responsible for bringing our tools and workflows to our customers to help them set up a meaningful tool chain to support with all the challenges that comes with complex models, modeling, config management, and version controlling. As you can see, Git is one of my favorite topics. So let's take a look into the topic of today. SysML v2 is here, so it's not just in theory. Since last autumn, so September, it's officially available as a standard. It was passed by the OMG. And now we have to think, how do we work with this new model language? How do we deal with the different views that we have? And now that we see new tools coming up on the market, how do we incorporate this into our daily work and into our already common and used processes? And first thing that is quite new to SysML v2 is that it is based on a new meta model on kernel, the kernel modeling language. So it's not based anymore on UML. So there's a quite drastic change. And on top of this as well, there are new ways to visualize the model. So we have the possibility to visualize the model in a textual representation. And this textual representation is very much as source code, you could say. It looks like source code. It has a very similar style, syntax-like. It uses curly brackets, semicolons. So if you know coding, then you can quite easily read this. And this is quite convenient because it's quite accessible for text-based tools, and artificial intelligence can deal with this quite well because it's text. So this is the new cool stuff that you have in systems engineering. You can basically code the model. And this sounds all very interesting, and it is, of course. It's a very cool addition to the systems engineering community. But it's only one side of the coin. The other side of the coin is that we still have a graphical representation of the model. So the classical diagrams that you know from the version 1. And the nice thing is you can use whatever you want. You can use the textual notation, you can use the graphical notation. Both are valid representations of the underlying model. So it's not that one of the other is the leading format. Both are on the same level. You can even use them side by side simultaneously if the tool supports this, but there is no level or no basically competition between the two. Both are valid and both represent the model. Both are renderings of the underlying model. So basically, SysML v2 is not just code. It's based on a model repository, which can be visualized in two different view kinds, textual and graphical. So taking one model this Batmobile, which consists of an engine, a body, and a seat part, actually two seat parts. We have these representations, the textual representation on the left, the graphical representation on the right, and both represent the same model, but they use a different viewpoint to access and visualize the underlying model. And now, depending on which style you like or how you are basically aligned, you might have looked on the left, on the right side first. Some people are more textual oriented, some people are more visually oriented. That really depends. And for SysML v2, it doesn't matter. You can use one of the other or even both. Some things are easier to produce or read in a textual notation, and some things are easier to produce, read, or change in the graphical notation. But the thing is, both representations, they are based on the SysML v2 model data on the repository, and both are views. Depending on the tool that you use, this is realized in different ways, but all of the tools have, or I would say should have, an underlying model data, database, abstract syntax tree. However, this is realized, but the view that you're using to edit the model, either the textual notation or the graphical notation, is one of two possible views. The model data is still the backend. And if we now think of collaboration and how do we track changes, if you now take a look at the left side, the textual notation, since it looks like code, the first and obvious idea is you use version control systems, for example, Git. Then you can create multiple versions, you can tag the versions, and you can even have branches, compare the branches, and do whatever you want to do in Git. Git is very versatile, and Git offers quite a lot of support for version management. Git is one example. There are many other version control systems, but Git is the most prominent, also in the open source community. So I will stick with the example of Git. And if we now take this and put the textual notation in Git, this works because it's textual. Git likes text files. So technically, there is no problem. But why I'm talking about this? So if we think about the textual notation, so let's take an example. We have three models, and I will always talk about three models because that's state of the art in version controlling, that you always have a common base. So a base version or a base commit where you branch off. Even if it's not a branch, then still you have a base commit, so the common base. And then in this example, we have two branches, A and B, which represents two versions. And those two users work in these two branches and they change something simultaneously and work on this in this textual notation. If we now merge this, the standard process in Git is you would try to merge the branches, and then you can see something like this. So a textual comparison of what happens. And of course, you have to now interpret what is happening here, what are the changes. And if we then merge it, we get a result. And we, of course, have to interpret if this result makes sense, is consistent, and semantically correct. If you use a text-based tool, then of course you have syntax highlighting and then some validation and kind of syntax checking to see if the result makes sense. But of course, it's not considering the full dependency graph. If you have elements, typings, type references, feature typings, of course, in this textual view, this is not considered.
So now I do not really see the impact of having this merge here. So it's obviously not an automatic merge. I have conflicts because in the textual position at certain lines, this was changed in parallel, so I cannot really merge it automatically. So I have to select from the both versions what to change or what to take over. So in this case, what we suggest and what we are currently supporting with our tool LemonTree is what we call a model-aware merge. So having the different views, either graphical or textual, we represent this so that you are familiar with the model, because this is the format that you use to modify it. But we also interpret and visualize the model tree behind it. So we render the text as you see at the bottom, but we also visualize the model tree with all its relationships, feature typings, redefinitions, and everything that you have in the SysML meta model to better understand what happens in the different versions. And also important to show you the conflicts if something in parallel has been changed. And also if those changes, if you combine them, do make sense, and if they are even possible based on the reference structure. So one example would be, so if we go back to the texture model, I did not explain it in detail. If we take a look at the base model, we have a car, and the car consists of a part definition engine with a cylinder, a chassis with wheel and brake system, and some concrete assembly where we have a part of type engine and a part of type chassis. In the version A, we can now see that it was updated, so there is no engine anymore. Let's not talk about if this makes sense, a car without an engine, but the engine was removed here. So deciding if this change makes sense is on the review side, so someone has to contribute to that. But we have this in the version here, the engine and the engine usage in the assembly got removed. And on the other side, we can see the engine is still existing, so it was not touched here. There was some slight modifications done in the brake system, in the chassis. And the part dev body was added, and in the assembly, the engine usage was even further changed. So we added a part of ignition that we call ignition. So we can see not directly changes which are conflicting, but in the usage of the engine, we can see that in the version B, there was something added, and while in the version A, this whole concept of the engine and its usage was removed. And of course, this is now me interpreting this because I know what I did. In the textual notation, I have to interpret this as well. And in our model-aware merge, we try to make this easy to understand by highlighting the different change types with different colors. So for those of you who already used LemonTree for UML and V1 might be familiar with this. So for example, a green element is an added element, a red and crossed through element was removed, orange means modified, and then there are some other color types like this light purple, which means sub-elements modified, and there's also blue for movings, if you move an element from one package or namespace into another. And here we can see the same representation, the texture notation at the bottom, but also the interpreted model tree. And here I want to highlight specific changes. So on the left side, we have an impacted element, which is the engine, the part diff engine. And this part diff engine is unmodified on the left side. It's also, we have the engine part that got some cylinder added here, or has the cylinder here. And on the right-hand side, in the middle, we see that this engine was removed. So not just the engine part of itself, but also the part engine of type engine, so the part usage. And this, of course, has an impact on the model. And the suggestion is to also remove it in the merge target, as you see on the right-hand side in the third column, because this has to be resolved. You cannot take the removal of the engine but still keep the usage. This would end up in an inconsistent model, of course. And here I also want to point out something else that is interpreted. I talked about the ignition part, that this ignition part is a subpart of the engine usage that we added in the left version. And you can see here this ignition part is flagged as conflicted. You can see this with the red exclamation mark and the icon that is added to its entry. And usually, if you add a new element, this cannot really be conflicted, because if it's new, it's only existing on this side, it cannot be in conflict with the other side. If you just take a look at this one element, yes, that's true. But if you take the full model into consideration, it is actually conflicted, because the owning membership pointing to the assembly is conflicted, because also the parent, the engine part, that is the parent element of the ignition, got removed. This is what you can see here in this tree here. The engine, which is part of the assembly, got removed, as well as the sub element of the ignition got removed. So adding this doesn't make sense, since the parent element was also removed. So I can only take the full tree where everything exists, or I have to remove it in the result. I cannot merge a half model, which makes it inconsistent. And this is pointed out here. That's why it's marked as conflicted, to highlight this change to you, so that you know you have to do something here and decide how to deal with it. Maybe go back to the modeler and ask why this got removed. Does it make sense? And with this, you have a much better discussion base to find out if the change makes sense, and if the change also is conflicting or makes the model inconsistent. So how did I come up with these comparisons? So I used Git to version control my models. Since I mentioned the SysML format, in this case, the textual notation I use is stored in a .sysml file. I simply version control this. Here I'm using a GitHub project and SmartGit as a Git client. I committed my model. I did 2 changes in 2 branches, and then I'm comparing these 2 branches. So here's my base, my starting point. Then I created a branch here. Based on the develop, I created a second branch, and this is actually where the 3-way comparison or merge is happening. It takes the commit from the develop, which is the origin point. It then takes the 2 versions, calculates the differences, identifies conflicts for parallel modifications, and then tries to merge it. So similar as for software development, when you use source code, usually you can auto merge if there's no conflicting changes. But if there is a conflict because you touched something that affects the other side, or you even touch the same elements, then this is not possible to be merged automatically. And in this case, some human has to act here and has to decide how to resolve the conflict. So it doesn't matter which tool you use, because we're currently based on the texture notation, but also on the exchange format, the JSON format. So there's in the standard a definition how to exchange SysML v2 models between different modeling tools. And this is what we currently support, the exchange format in the form of JSON and the texture notation. And I see here there's a question popping up already for the texture representation, if we support it completely. The question currently fits perfect. That's why I'm addressing it. We are supporting the JSON in the full scope. The texture notation, since we implemented our own parser for this, is not yet fully completed. On our help page, there's a documentation of which concepts of the texture notation we already support. But this will, of course, follow. So we're committed to supporting it fully. So texture notation at the moment is not fully implemented in the preview version. The JSON format, so the exchange format, is already fully supported. So this is the current state, and I will come back to this later, also talking about the current state and what you can try out with the current preview version that we have. And so in this example where I'm using Git, the textual notation is the entry points. It could also be the exchange format, the JSON that is delivered through either the tools that are exporting it or through the APIs that are capable of exporting or saving revisions of their modeling database or repository. So, for example, it could be Jupyter Notebook, so I can use the textual notation in Git, or as you can see here, I can use the same model in Jupyter Notebook, render it, and then export this. This will create a JSON file, and this JSON can also be used for diffing and merging. So if you use the textual notation, the merge result will be again a .sysml file. If you use the exchange format, the .json, then the merge result will be a .json. So you can also write it back to the tool to get the data, the merge data back to the tool and continue with your work. So the idea here is, doesn't matter if it's the Jupyter Notebook, this supports the textual notation, or Rhapsody, for example, can also export JSON. You can create elements based on the textual notation. That's also possible. We also did a quite nice integration with OpenMBE. So here we're working together with Robert Carban from Planetary Utilities. Here is a YouTube video. I'm not going to play it now, but it will be part of the slides, and you will get access to this link where there's a demonstration of all the tools that you can see here. So OpenMBE using MMS Flexo, Starforge, and Seaside for the texture notation. So you can see here also those tools are integrated into this tool chain simply because these tools, they talk to each other through the JSON for exchange or the texture notation. So this is a very nice integration as well. So highly recommend to check out what we're working on here. And there is more to come in this distributed model management using OpenMBE and MMS Flexo. And overall, the goal here is to support multiple tools which are talking in a SysML v2 language. So I mentioned already the Jupyter Notebook. I mentioned OpenMBE and Flexo, Starforge, Seaside. Basically any tool supporting JSON. You can also see here Enterprise Architect. So the SysML v2 tool called Tricoro, which will come in the course of this year. So this will of course also be supported since we support Enterprise Architect, diffing and merging with the current LemonTree version as well. So that's the main vision, to be the central diffing and merging tool for the SysML v2 standard based on the official files, file format, texture representation, and the exchange format. So that basically sums up what I just said, the vision that we have with LemonTree. So having the CI/CD capabilities for SysML v2. So having everything maintained in Git, having the orchestration through the version control system opens up the possibilities to run CI/CD pipelines. So automatic comparison, writing comparison results, preparing review artifacts. So the same strategy that we use for version 1 and UML, we also are providing for SysML v2, of course. Then diffing and merging SysML v2 models from different modeling tools or data sources. Talking about migration, that's also an important topic. So we want, or we will also support handling the combinations of v1 and v2. This is especially interesting for Spark's Enterprise Architect Tricoro, because there will be a combination of UML, SysML, and SysML v2 to document the transition and document the migration path. So those models will be handled in parallel, might also have connections to document this. So since we already support v1 in this case, this bridge will also be possible. And further down the road, supporting the graphical representation. At the moment, you saw in this preview that I showed you solely the model tree as well as the texture notation. And later, the graphical representations or rendered views will also be supported, visualized, and used for change highlighting. This is pending on the standardization of a standardized diagram exchange. This is already in progress, and there's very good work done in the diagram interchange working group at the OMG, where we're also in communication and contribute our input to. So this will later on be part of the official language, and once this is established, it will also be considered and supported by LemonTree for diffing and merging of the graphical views, so the graphical representation. And everything that I showed to you in these screenshots so far is based on the preview version of LemonTree for SysML v2, which supports the textual format as well as the exchange format, as I mentioned. Since the slides will be publicly available and you will have a summary sent with our newsletter, there you will have the download link, also the link to the help page where you can see what is already supported. You can try it out. And of course, I will demonstrate this now to end this here, not just showing you screenshots. So I will show you what I used before as a screenshots now in the Git environment. So I will step out of the presentation and switch back to Git. So here, this is exactly the example that I showed to you before. So I have a main commit here in the develop branch, and then I have two branches where I modified the car SysML model. So that's the same model that I showed to you in the slides. And the integration is fairly simple. So Git itself does not know how to properly diff and merge this. So if I wouldn't configure anything, then Git would just try to do it textually, because from the perspective of Git, that's a textual file, which fair enough, it is a textual file, but to do it interpreted and the model aware merge, we have to tell it to use LemonTree in order to do this proper model aware merge. And this is fairly simple. You can simply configure a diff and merge tool. For example, here I'm using the integration that we have with Enterprise Architect as a basis. I would just copy it and say, do the same principle. So getting 3 files as parameters using the LemonTree application. If you encounter any file of this pattern, so for all .sysml files. And now if I take these two branches here and I want to see what the difference is, I simply say show changes. And now it will detect that rather than using a textual comparison, it will use the LemonTree diff. So it will run a 3-way comparison because it has the common starting point, the base version. So the commit from the develop, and then it has the 2 versions from the 2 branches. And now I have multiple ways to analyze the changes. If I'm familiar with the model tree, I can click through the model tree here and take a look at the different changes. If I want to go through the different elements just randomly, but here you can see it's in an alphabetic order, I can use this list here. Or if I'm more familiar with the texture notation, I can also use this and jump to the corresponding element in the model tree. So for example, here, the chassis element, if I click on this magnifying glass, it jumps to the element in the other panels so that I know where this element is, what it has as sub elements, and can see what the change is. And here I'm currently in the comparison mode, so I only see the 2 columns, which shows me the comparison between this version to the base and that version to the base. So now I can easily find out what has been changed. For example, here this trunk part has been added in this version. It's part of the body. Or here in this the assembly, we have a conflict because the owning membership and also the owning part got removed on this side, but on the other side, this owning element was actually modified because a new item a part ignition was added to this engine part. So here in this case, I have to decide how to deal with this. If I want to merge this, for example, then the suggestion is to not take it over and remove it. That's what I can now change. I could, for example, say I want to take this ignition element here, but once I do this, I have to take over the overlying structure here as well, because I cannot just take the ignition part. It would just lie somewhere in empty space. It has to go with the owning membership, the engine parent within the assembly. So it ensures to have a consistent model once you merge it. And this is very important because otherwise you end up with something that doesn't make sense or maybe is inconsistent. And I can use this now to go through the model to deal with the conflict. So maybe here, this conflict of ignition I solved. So I click here. Now I have 6 conflicts to go. Now I take a look at this here. So that's the owning membership. I already solved this by the ignition. So I click here. And then I can go through all the conflicts. I can even reduce the view to just show me the conflicts here. So I can go through and check if I missed something in the car. Let me see what we have here. Basically, it's populating the conflict here so that we see what I have to touch. So in the assembly, again, the owning membership. And this is very useful so that I can go through all the conflicts. So this might be familiar to you from software development, where you can go through all the changes, resolve the conflicts. And once I'm happy with this and I have 0 conflicts left, I can start the merge and write this back to the Git environment to continue with the work. So this is how we solve that. And of course, I could also do this with a JSON model. So this is the second example that I have. So here I have an excerpt of the Apollo 11 model. In this case, I added it as a JSON, so it's not detection notation, so it's a bit much more complete. So if I now have the same scenario, a base commit and then 2 branches, I can compare these 2 branches, pass it over to LemonTree and take a look at what has been changed. In this model, we have a lot of changes in the short names as well as in some concrete attribute values, which on purpose are changed in a conflicting way. So a lot of literals and a lot of attributes have been changed on both sides, which results in conflicts. And these conflicts, they will be shown to me. So quite a lot of changes. So I did this in an automatic way. So to show you how we also deal with a lot of conflicts which are displayed. So for example, here, this attribute usage, it has a feature value, and this value here was changed in both versions. Again, if I switch to the merge mode, I can see how this merge can be then populated. So I could say I want to take the version from this side, or maybe the other version if I want to. So with this, I can go through all the conflicts, review them, and also decide how to take over this value. So to wrap it up, if you want to try this out with your models, either the texture notation or the exchange format, happily reach out to us and get the preview version, read the documentation of what we currently support. We can also schedule a meeting to discuss other ideas and inputs you have. And basically, what we want to support is having the SysML tools connected to each other using SysML, using LemonTree for SysML v2 to have a diff and merge tool, support common practices from software development, because we think that every change matters, and that's why you should use LemonTree to see the changes, detect conflicts, and resolve them while performing systems engineering. So thanks for your attention, if you're interested in talking, discussing, you can contact me, find me on LinkedIn. And now we have a few minutes for addressing questions. So let me see if there are some questions.
Thank you, Philip. There are two open questions regarding the conflict detection of properties for single element, but I think we've seen this. Maybe you can elaborate on this in the chat. You have to open the chat if you want to see the question. I can also read it.
Okay. Yeah, because we have the answered questions. Okay. Okay, sorry, it was about the audio. So there's one question if it will work on Linux. Yes, it will work. We support Windows deployment as well as Linux deployment, both for our desktop client as well as for the CLI version.
And the other two questions are in the chat, not in the Q&A section.
Yeah, there is the question. So do you support conflict detection of properties and internal structure of a single element like name change, connector ends, payload of an accept action and such? In general, yes. The name change is a little bit tricky depending on the format that you use. A name change, as you might imagine, is tricky because of the fully qualified name. So if you use the textual notation, the identification for the element to be matched between the versions is in fact the name plus its full namespace, so the so-called full qualified name. Meaning if you change the name at the moment, this will result in not being detected as a change rather than a new element. This will be improved in upcoming versions as well as later down the road in the SysML standards, because there will be ways to introduce identifiers also in the textual notation. As far as I understood, and my latest knowledge is that it's not mandatory, but you can add IDs as well to the textual notation. And if you have IDs, of course, you can change the name. Then the ID is the basis for comparison. Regarding the exchange format, a name change, of course, is not a problem because the name change is then not affecting the identifier because there is an identifier. However, we have seen tools which are currently not consistently updating the IDs. So not all tools at the moment generate the same IDs for new versions of the same model. But I guess this is also just a matter of time and will be fixed in the future. So if the ID is consistent, we detect it. And if we then have a proper ID mechanism, it's even more stable. And regarding the other properties, name change, connector ends, yes, of course. A payload of an accept action and such, yes, of course, that will also be detected. Same as you see literals, so attribute values, requirement, text, documentation. So yes, this will go down to the very lowest level. So anything will be detected here. And for the future as well, also the graphical information. So changes on the visualizations, on diagrams, this will also be detected and can be visualized. So even if you only change a view or a diagram, this is still relevant to the viewer or might be relevant. So this can also be highlighted. The next question is, can I use a kpar file as a starter? One kpar file has a collection of SysML files. At the moment, no. But so the kpar is, as you said, an archive, a combination of multiple SysML files. But this is also something we will offer in the future because not always you will have the entire SysML model in one file. It will be distributed and will be referenced by imports, for example. So this will be relevant also for the diff and to load it in a container in a combined way. So the kpar might be an entry point for this, or a folder where you store the textual notation files. So at the moment, it is based on single files, so JSON or .sysml files, but if it will be exactly the kpar or any other container, this is still open. But yes, there is a need for supporting a collection of files that reference each other, because you might distribute different parts, part defs, or other namespaces to different files. Okay. So I think there are no more
Yes.
questions.
Exactly.
Okay. So thanks everyone for joining. And if you're interested in trying it out or discussing with us about SysML v2, reach out to us. Slides or video recording of the webinar will be available, and we can also send out the download link to the preview version. So thanks again. Have a nice rest of the evening, day, and see you next time. Thank you. Bye-bye.